Alpha Centauri has always sparked dreams of new worlds. What if we could travel there and build a whole new society? This might seem like something out of a movie, but scientists are already thinking about how to make it happen. But first, we need to figure out how to travel there and create a safe place to live. Life on Earth faces increasing challenges as humans battle against massive problems like climate change and its ever-worsening consequences. People often wonder if humanity could possibly live on another planet. Alpha Centauri has become a focal point for potential space colonization for several reasons. Firstly, its proximity makes it an attractive target. It is the closest star system to Earth and located about 4.37 light-years away, which is about 25 trillion miles. This is a 3-star system that consists of Alpha Centauri A, Alpha Centauri B, and the red dwarf Proxima Centauri. It offers a relatively reachable destination compared to other star systems. The system also has a unique binary structure. It contains not just one, but 2 stars similar to the Sun, doubling our chances of finding other planets in either of their habitable zones. In fact, that gives us an estimated 85% probability that the system harbors at least one potentially habitable planet. Although the binary structure increases our odds, it also presents challenges. In order to take the photograph, we have to use a specialized system to efficiently suppress the light of 2 stars to see any potential surrounding planets. Finally, the last reason our focus remains on our neighboring star system is that Alpha Centauri A is a yellow G2 type star that has a temperature and color that closely match with the Sun, thus increasing the chances of the existence of an Earth-like planet. B is a bit cooler and redder than our Sun, but it's also still a good candidate to host a rocky planet like Earth. Proxima Centauri is the dimmest and closest of the 3. It is just 4.22 light-years away. This star is thought to be gravitationally bound to Alpha Centauri and Beta Centauri, which form a binary star system 4.3 light-years away from us. Alpha Centauri is the brightest star in the constellation Centaurus. It is named after the mythical half-human and half-horse creature. The star represented an uncharacteristically wise centaur that figured in the mythology of Heracles and Jason. Heracles accidentally wounded the centaur and placed it in the sky after the death of Zeus. It marked the right front hoof of the centaur, although little is known of its mythological significance. The Scottish astronomer Thomas Henderson first calculated its distance in 1839. It was marked as one of the earliest efforts to measure stellar distances accurately. Over the years, improved techniques and instruments have refined these measurements by solidifying its place in astronomical studies. The star holds a special place in the mythology of various cultures, particularly in the southern hemisphere. For the indigenous Ngarrindjeri people of South Australia, Alpha Centauri and Beta Centauri were seen as 2 sharks chasing a stingray, which is represented by the stars of the Southern Cross. Ancient Polynesian navigators used these stars as crucial markers. These are known as Kamailiope and Kamailimoa, which helped guide them across vast expanses of open ocean. The Inca civilization also integrated it into their celestial mythology, where the stars represented the eyes of a llama, formed by stars and dark dust lanes in the Milky Way. In modern times, the obsession with the star system has shifted toward the search for exoplanets. It involves the possibility of life beyond our solar system. So in the past decade, astronomers have been searching for planets around it. So far, 2 planets have been found orbiting Proxima Centauri, one in 2016 and another in 2019. A paper published in February 2021 reported evidence of a Neptune-sized planet around Alpha Centauri A, but it has not been definitively confirmed. However, the key question remains: what's the best way to travel to Alpha Centauri? One proposed method is known as nuclear pulse propulsion. It involves propelling a spacecraft using a series of nuclear explosions. This concept originated from Project Orion. It would be suitable for large missions and potentially sending a colony-sized ship across the stars. Another promising approach involves using light, or laser sails. These sails would be propelled by powerful lasers fired from Earth with the help of continuous acceleration. It aims to reach the start in about 20 years by achieving speeds up to 15 to 20% of the speed of light. This technology relies on overcoming challenges such as heat dissipation and material durability under intense acceleration. Antimatter engines might work. These drives rely on the extraordinary amount of energy released when antimatter and matter annihilate each other. However, current antimatter production and storage capabilities are insufficient, presenting a major hurdle. Bussard ramjets are also designed to collect interstellar hydrogen as fuel. However, it faced significant challenges due to the low density of the interstellar medium and difficulties in utilizing pure hydrogen for fusion. For missions spanning multiple lifetimes, suspended animation or generational ships where future generations continue the journey are considered viable. This ensures that the original crew's descendants reach the destination if faster-than-light travel remains unattainable. But traveling there presents many challenges, primarily due to the vast distance involved. With our current propulsion technology, such as the speed of Voyager 1, which is 35,700 miles per hour, it would take around 70,000 years to reach Alpha Centauri. To make interstellar travel feasible, faster propulsion methods must be developed, which is a major scientific and engineering challenge. Another challenge is energy requirements. The energy needed to sustain a spacecraft over such a long journey is huge. Alternatives like nuclear power, which can provide a much higher energy density, are being explored. Maintaining a stable life support system over decades or even centuries is another critical challenge. A spacecraft must provide food, water, air, and waste recycling for its crew. Innovative agricultural techniques such as hydroponics and aeroponics will be necessary to produce food in space. Moreover, the ship must be designed to handle all aspects of human life, including medical care, social structure, and psychological well-being. Extended exposure to space environments causes several health risks to humans. Microgravity can lead to muscle atrophy and bone loss, while radiation from cosmic rays increases the risk of cancer. Solutions might include artificial gravity generated by rotating sections of the spacecraft and advanced shielding to protect against radiation. Proposed solutions include using a secondary laser array at the destination to decelerate the craft. Navigational accuracy is also crucial to avoid collisions with space debris and ensure a safe arrival. The future of the star is filled with exciting possibilities. The current technology would take tens of thousands of years to reach the star system. NASA and other space agencies are exploring advanced propulsion, which could significantly reduce travel time, potentially making such a journey feasible within a few centuries. One of the most notable projects is the Telescope for Orbit Locus Interferometric Monitoring of our Astronomical Neighborhood mission. It's otherwise known as Ptolemy, which targets stars within 10 light-years of our Sun, including Alpha Centauri. Ptolemy is designed to search for potentially habitable planets around Alpha Centauri A and B by making extremely fine measurements using a small and custom-built space telescope. This mission represents a significant step towards understanding the planetary systems in our immediate cosmic vicinity. Another significant initiative is the Breakthrough Starshot project, which aims to send small and light-propelled probes to Alpha Centauri at a fraction of the speed of light. This project is backed by figures like Stephen Hawking and Yuri Milner. It aims to capture images and data from the system within a few decades, despite the current technological and engineering challenges. While the dream of forming a civilization on Alpha Centauri remains distant, the progress made in space technology brings it closer to reality. Could any of the planets around Alpha Centauri be our new home? Share your thoughts in the comments below. Hopefully you enjoyed this exploration of interstellar societies, and make sure to subscribe for more.